Welcome to today's lesson. Today we are going to continue looking at solving equations. Today's questions involve equations where the variable appears more than once. We'll take a look at our first question, which is 5a plus 9 equals 3a plus 12. What we need to do is we need to isolate a by itself and get an answer that is a equals a value. Our problem is a appears more than once. We have a term that contains 5a and a term that contains 3a. For these questions, we must try and rearrange the equation so that a only appears once. Once we've done that, we can use our methods from our earlier lessons to solve these equations. So what we do is we underline all of the terms that contain our variable. So these are 5a and 3a. We need to look at these terms and decide which term is the smallest. Well, out of 5a and 3a is the smaller term. Once we've found the smallest term that contains the variable, that's the term that we need to try and do the opposite operation of. This 3a and 12 are being added together, so I need to do the opposite operation of adding 3a. The opposite operation of adding 3a is subtracting 3a. So we'll write a minus 3a underneath 3a. If we're subtracting 3a from one side of the equation, we also need to subtract 3a from the other side of the equation. Because we can only subtract like terms, we will write the minus 3a underneath the term that we underlined, which is 5a. I'm now going to draw a line and we need to combine these together. So 5a take away 3a leaves us with 2a. There's nothing underneath this plus 9, so that's just going to drop down. The equal sign will drop down. 3a take away 3a will cancel each other out, so nothing will be written here. And plus 12 has nothing underneath it, so the plus 12 will just drop down. So we now have 2a plus 9 equals 12. This is exactly the same difficulty as the equations we were looking at in previous lessons. So now we need to try and isolate the term, and then we need to isolate the variable. The term that contains the variable is 2a, so that's what we're going to try and isolate. So we need to do the opposite operation of adding 9. The opposite of adding 9 is subtracting 9, so we'll subtract 9 from both sides. 2a will drop down. 9 take away 9 is nothing. The equal sign drops down. And 12 take away 9 is 3. Now we need to isolate the variable, which means I need to get a just by itself. So the opposite of multiplying by 2 is dividing by 2. 2a divided by 2 is just a. The equal sign drops down. And 3 divided by 2, the good thing with algebra is you can leave that as just 3 over 2, but you may have worked it out as a decimal, and if you did, we would get 1.5 as the answer. On to the next question. Just like the last question, our first step is to identify the terms that contain the variable. So we have 4a, and we have minus 2a. Again, it's really important that we include the symbols before each term. So this term isn't 2a, it is minus 2a. Out of these two terms, which term is the smallest? Well, that would be minus 2a, because minus 2 is smaller than 4. We now ask ourselves, what is the opposite operation of subtracting 2a? Well, the opposite of that is adding 2a. Because I've done that to the right-hand side, I also need to do it to the left-hand side underneath the other term containing a, and we add 2a to both sides. 4a add 2a is 6a. The takeaway 11 will drop down to the next line. The equals will drop down to the next line, and the 5 will drop down to the next line because there's nothing underneath any of these terms. The minus 2a and the plus 2a, well, that's 0, so they cancel, so we don't write anything on the next line. So, with 6a take away 11 equals 5, now we try to isolate the term. The term that contains a is 6a, so we need to undo the minus 11. That means I need to add 11 to both sides of the equation. 6a will drop down. Minus 11 and add 11, well, they cancel. The equals sign will drop down. And 5 add 11 equals 16. Now we need to isolate the variable. So we have 6a equals 16. So the opposite of multiplying by 6 is dividing by 6. 6a divided by 6 is a. The equal sign drops down. And then 16 divided by 6, well, I know that 16 isn't in my 6 times table, so I know I'm going to get a decimal answer. Rather than worrying about what the decimal answer is going to be and having to do a bus stop method, because we're working with algebra, I'm going to leave my answer as 16 over 6. Our next question is 12 take away 5a equals 21 take away 7a. Again, we start off by underlining the terms that contain our variable. They are minus 5a and minus 7a. We ask ourselves, which of these terms is the smallest? Well, is minus 5 smaller or is minus 7 smaller? Minus 7 is smaller, so therefore I need to do the opposite operation of subtracting 7a. That would be adding 7a. So we now combine these two lines. 12 will drop down as there's nothing underneath it. Minus 5a adds 7a. At this point, you may need to use a method with counters in order to make sure we don't make any mistakes with our negatives. We're trying to do minus 5 and then add on 7. That would give us a positive 2, and obviously that would be positive 2 lots of a. The equal sign drops down, as does the 21, and then minus 7a adds 7a will cancel each other out. A reminder, our goal after this first step is to get an equation where the variable only appears once, because then we can use our regular methods in order to solve the equation. We now need to isolate the term, and the term that contains a is add to a. Therefore, we need to get rid of 12. This 12 and 2a were being added together, so the opposite of adding 12 is subtracting 12. The 12s cancel each other out. The positive 2a will just drop down to the next line. The equals will drop down, and then 21 take away 12 leaves us with 9. We now need to isolate the variable, which means I need to just get a by itself. So what would I do here to undo this from our 2a? You need to be careful here The plus 2a just means that it's a positive 2, but it doesn't mean we're adding 2 to a. Otherwise, the add symbol would be between the 2 and the a. This means we are multiplying a by positive 2. In reality, we don't need this positive symbol here. We could just write 2a equals 9. To undo the multiplying by 2, we need to divide both sides by 2. So 2a divided by 2 is a, and 9 divided by 2, again, we can write it as a fraction, or if you know what half of 9 is, a decimal would also be accepted with 4.5. Our next question is a bit more difficult. We've got 4 lots of 3a minus 2 equals 9a plus 10. Usually we would highlight the terms that contain our variable. However, because we have a 4 and a bracket, this left-hand side at the moment is just one big term. So we can't do anything with this 3a until we've dealt with the brackets. This means we're going to have to expand the bracket before we can combine the terms with a together. So we're going to have to use our expanding bracket method. This means I've got 4 on the left hand side, 3a across the top with a minus 2. 4 times 3 is 12, so 4 times 3a is 12a, and 4 times minus 2 is minus 8. Therefore, I can write 12a take away 8 underneath this bracket. Everything else in the equation, so the equal sign, the 9a and the plus 10, I have not used those in the expansion, so these are all going to drop down to the next line. We now have an equation that we've been looking at today. So we have 2 terms that contain the variable, so we need to decide out of these terms which term is the smallest, and then we undo that operation. 9a is smaller than 12a, so we will subtract 9a from both sides. 12a take away 9a is 3a. The minus 8 and the equals were not used, so we'll drop those down. 9a take away 9a, they equal 0, so we don't write anything here. The plus 10 was not used, so we drop that down. We now have an equation with just one variable, so now we need to isolate that term. So we need to undo minus 8, so we add 8 to both sides. The 3a will drop down. The minus 8 and the plus 8 will cancel each other out. The equal sign drops down, and 10 add 8 is 18. Then we isolate the variable. So we divide both sides by 3. 3a divided by 3 equals a. The equal sign drops down, and 18 divided by 3 equals 6. So our final answer for this question is a equals 6. Question 5 is 2a minus 3 equals 5a minus 3 all over 4. Much like the last question, we can't start manipulating the terms that contain a straight away because we've got a fraction. Our rule is we can only manipulate equations when there's no brackets in the equation and when there's no fractions in the equation. So what we need to do is we actually need to isolate the numerator away from the denominator. This means we need to undo the divide by 4? Well, to undo divide by 4, we multiply by 4. What's really important to remember here, however, is that when we're multiplying, we need to multiply every term in the question by 4. So it's not enough for me to just write a times by 4 underneath the 2a. I also need to write it underneath the minus 3. The reason why we only need to write it once underneath this 5a minus 3 divide by 4 is because all of it is being divided by 4, so timesing it by 4 once will cancel out all of that division. So, multiplying by 4, we get 2a times 4, which is 8a, minus 3 times 4, which is minus 12. The equal sign drops down. 5a take away 3 divided by 4 times by 4. The 4's will cancel out completely, just leaving us with the numerator. So we're going to write down here 5a take away 3. We now have an equation where we have two unknowns. Which of these terms is smallest? Well, that is 5a. So how do I undo 5a? Well, it's important to realise what 5a is doing with minus 3. This is a positive 5a, and then 3 is being subtracted afterwards. This minus sign belongs with the 3, so because 5a is positive and we're adding or subtracting here, we need to subtract 5a in order to get rid of 5a. Doing this to both sides, we have 8a take away 5a is 3a. The minus 12 in the equals sign will drop down. 5a take away 5a is nothing, so we don't write anything here. And the minus 3 will drop down. We now need to isolate the term, which is 3a. So we're going to add 12 to both sides of the equation here. The 3a drops down. Minus 12, add 12 cancel each other out. The equal sign drops down. And minus 3 add 12 is the same as 12 take away 3, so that's 9. So then to isolate the variable, we simply need to divide both sides by 3. So our final answer we get is a equals 3. The final question for today is a over 2, add 5 equals 2a minus 3. Again, we cannot start manipulating the terms involving a because we've got a fraction. I need to isolate this a term away from the fraction, so I need to undo the division by 2. To do that, we would multiply by 2. Again, because we're multiplying, it's important we multiply every single term by 2. Here, we do need to multiply the add 5 by a 2 because it's not within the fraction, so it's not the same rules as the last question. We also need to multiply the 2a and the times by 3. This gives us a plus 10 equals 4a minus 6. We now look at the terms and decide which terms that contain a is the smallest. That would be a, so I need to get rid of that a by subtracting a from both sides. A take away a cancels out. The plus 10 will drop down. 4a take away a is 3a, and the minus 6 will also drop down. Now we isolate the term. That's 3a. So to both sides I need to get rid of minus 6. So that means we will add 6. 10 add 6 is 16. The 3a will drop down. And the minus 6 and the add 6 cancels each other out. And to isolate the variable, we need to get rid of the multiply by 3. So we will divide both sides by 3. Well, we'll start with the right-hand side here because it's slightly easier. 3a divided by 3 is just a. I've got 16 divided by 3. 16 is not in the 3 times table. So rather than worrying again about a decimal answer, we will leave our answer as 16 over 3. It doesn't matter that a is on the right hand side of the equation. This answer is the same as writing a equals 16 over 3. And that concludes today's lesson on equations.